Hello everyone and welcome back to our function study. What we did in our very first video was the domain, limits, and the asymptotes of this function. In the last video we did our first derivative and we found out what the extremes are, the minimum and maximum. And now let's come to the point D, where we calculate the second derivative and determine inflection points. I will also explain what that means. Okay, so I've written the formula again here, the function. And what we do now is, the second derivative is basically the derivative of the first derivative, right? So we take a look at this. Now we have once again this formula that if the function is a fraction, this is how we derive it. So that is what we're going to do here. Once again, let's take u equals to minus x squared minus 3x minus 1. U derivative minus 2x minus 3. V equals to exponential x plus 1. And the derivative of an exponential is the exponential. And what we do now is we simply put in. Okay, so we take minus 2x minus 3 times ex plus 1 minus x squared minus 3x minus 1 times ex plus 1, and all of that divided by ex plus 1 squared. As in our first derivative, all of this multiplied by exponential, so we can simplify and we get minus 2x minus 3. Now pay attention when we open up this parenthesis because there's a minus in front, so we have to take that into consideration, plus 3x and plus 1 divided by exponential x plus 1, and this leaves us with plus x and minus 2 equals to exponential ex plus 1. Okay, now just like for the first derivative, we want to know when is the second derivative 0 for which x. So we're going to do the delta once again equals 9, and if we apply the whole formula, we will find out that this is x1 equals to minus 2 or x2 equals to 1, which means that at minus 2 or 1 the second derivative is equal to 0. Now what we do is just like for the first derivative, we take here, now we have minus 2 and we have 1. We found out that at these two equals 0. Let's just look for a value in between. Let's say 0 is the easiest one. We put it in here, we get minus 2 divided by, so this is going to be minus, and this means that the other ones are going to be positive. Now, what did we find out with this? We found out that since here we have a changement of sign, this is an inflection point. Inflection point at minus 2 and at 1. Okay, this is an IP. And what did we find out here? We found out here it is positive, here it is minus, and here it is positive. This is basically the direction of the curve of the function that we just found out. When it's positive, it goes up, and when it's negative, it goes down. When it's positive, it goes up again. Okay, so there we go. Now, what we still need to do is find out what coordinates those inflection points actually represent. Okay, so let's just say that we take, in order to find inflection point 1, we know that x is minus 2. What we have to do is we put in minus 2 here, and if we put minus 2 in here, we get 6 plus 5 times minus 2 equals minus 10. 6 minus 10 equals to minus 4. Minus 2 squared is plus 4. We have minus 4 plus 4, which is equal to 0. So this is the coordinate for the first inflection point. And the second inflection point, we found out that x equals 1. Now, if we apply 1 into this formula, we find out that it's 6 plus 5 plus 1 equals to 12 divided by e1 plus 1 exponential 2. If we just calculate this, this is the same as 1.62. So now we found these two inflection points. And this is all we need to do for this step. Now we are finally ready to draw this function, and that's what we're going to do in the next video.